So now we're going to talk about the atom, right? Which again is something that you have to have a fundamental understanding of in order for you to appreciate chemistry and chemical reactions and so on. So let's define what we mean by this term atom. An atom is basically the smallest particle of an element that can exist. All right. So in other words, if you have, let's say, a piece of sodium, and if you're able to break it down to the very smallest unit, then you're going to end up with an atom of sodium, right? So that's basically what we mean by the atom. Another definition is that it's the smallest unit of an element that can enter into a chemical reaction. So these two definitions are pretty much describing the same thing. Okay, now one important thing about the atom that you need to be aware of is that even though the atom is the smallest part of an element, there are actually other particles that exist within the atom. And we call these particles subatomic particles, all right? So as stated here, the atom is very small, and it is so small that if you consider this dot here, where the diameter is 1 millimeter, then if we're thinking about the hydrogen atoms, for example, and you line them up side by side from one end of the circle through the middle to the other end of the circle for this dot, then basically the number of hydrogens required for that would be 10 million hydrogen atoms, right? So that gives you an idea as to how small these particles are, right? But even though you have those small particles, as I said before, there are even smaller particles that exist within the atom, and these are called subatomic particles. So, what are these subatomic particles? Well, we have protons and neutrons, right? And these particles are located in what is called the nucleus of the atom, which is at the center of the atom, right? So we have protons and neutrons located in the nucleus. And then surrounding the nucleus, we have the electrons, all right? So that's basically a description of the location of these different particles. We have protons and neutrons in the nucleus, while we have electrons being dispersed around the nucleus. Now, in terms of the nature of these particles, this table here basically summarizes it. As you can see here, the proton has a relative mass of 1 unit, right? But the charge on the proton is +1. And as we said before, the proton is located in the nucleus. Now, if you compare that to the neutron have about the same mass as that of a proton. The difference is right here. The neutron has no charge associated with it, while the proton has a +1 charge. And again, the neutron is located inside the nucleus. And then now we get to the electron. Now, if you look at the electrons, which are surrounding the nucleus, the electrons, when you compare its mass to that of either the proton or the neutron, the mass of the electron is relatively very small, right? About 1/1800 times that of the mass of the proton or neutron. The charge on the electron is -1, and as we said before, the electron is located outside the nucleus. So this basically summarizes the nature of these three subatomic particles that can be found in most atoms. Okay, then the last thing we're going to talk about here is a special group of atoms known as isotopes. All right. Now, what are isotopes? Isotopes are atoms that have the same number of protons but different numbers of neutrons. All right. Now, the atomic number, some definitions here I have to introduce to you. The atomic number of an atom is the number of protons in the nucleus of the atom of a given element. So each element will have its own unique atomic number, right? And we're going to see some examples of that shortly. But there's another term I need to introduce to you, and that is called the mass number, right? The mass number is the total sum of the number of protons and neutrons in the nucleus of the atom, all right? So please note the difference between the atomic number and the mass number. The atomic number is the number of protons in the nucleus of a given atom of an element, and the mass number is the sum of the number of protons and neutrons in an atom of the element. And let me say, and I think I've said it before, but I'll say it again just in case, the atomic number is basically what is unique to each element, right? Each element has its own unique atomic number, right? So sodium, for example, if you were to look in the periodic table, you'll see that sodium has an atomic number of 11, and only sodium has that atomic number. Or another example would be, let's say, chlorine. Chlorine has an atomic number of 17, right? And chlorine is the only element with that atomic number. Now, based on these definitions, we can determine the number of neutrons for a particular isotope. All we have to do is find the difference between the mass number and the atomic number, and that will give you the number of neutrons, all right? So, for example, let's say you're given this question. The question says, how many protons, neutrons, and electrons are present in a barium-81 atom? Now, I think it's important for me to explain that what you're looking at here, in fact, tell you what, I'm sorry, I need to get out of this here. I think, whoops. Okay, I thought I had a table here, but I didn't. So let me explain something here using this example. Let me go back to my pen function. So what you're looking at here, we call this an isotopic symbol. All right, so let me say that this is what we call an isotopic symbol, all right? And basically, it's an abbreviated way of representing a particular isotope, providing some information about the mass number and the atomic number, number of protons and so on, neutrons and etc., electrons. So basically, I'm going to just write down a hypothetical isotopic symbol where we have A here, Z here, and E here, right? E here represents the symbol of the element. A here represents the mass number, and Z here represents the atomic number. All right? So basically, if you're given something like 3517 chlorine, right? Then we know that the atomic number is 17, we know that the mass number is 35, and we can find out what the number of neutrons would be. All right? Now, I'm going to use this example to illustrate. Now, in the case of bromine, I'd have to look up the atomic number of bromine. Let me just quickly search for that, because we need that in order to answer this question. Let me see here. In fact, let me cheat a bit here. So let me go to good old Google. Atomic number of bromine is 35. All right. So let me go back to this here and expand that. So basically, the abbreviated version or the isotopic symbol will be 8135Br. All right. So what the question is asking here is how many protons, neutrons, and electrons are present in the bromine 81 atom, right? 81 is the mass number, and 35 would be the atomic number. So based on the definitions, we know that the number of protons would be equal to 35, and the number of electrons will be the same, because in any neutral atom, the number of protons and electrons would be the same. So now we get to the question of the number of neutrons. And in this case, the number of neutrons will be equal to the mass number, which is 81, minus the atomic number, which is 35, and 81 minus 35, I'm too lazy to work that out in my head, so I'm just going to use my trusty cheap calculator here, and the answer here would be 46. And that's basically how you would answer this question, all right? So that's basically how we can interpret this representation here, which is called the isotopic symbol, to find out certain things about a particular atom in terms of the composition of the subatomic particles present within that atom. Okay, we're going to stop here for this video, and the next discussion topic in the next video we'll be dealing with compounds. All right, until next time.